Hello and welcome to Pre-Calc. Today is Thursday, September the 10th. We'll put the date at the top of our page. And our topic is graphing linear and quadratic on same axis. So we're going to graph two different functions on the same axis. Cool. Before we dive in, we're going to review slope-intercept form a little bit. We'll write this in our notes. We're going to put slope-intercept. Cool. We should know that's y equals mx plus b, where m is your slope and b is your y-intercept. Always remember to pause and rewind whenever you need. I'm going to say y int. Cool. Let's practice graphing a slope-intercept form really quick. We'll call this example 1. Our instructions are graph. And we're going to say y equals negative 2x plus 4. Cool. I've got my slope is negative 2. My y-intercept is 4. When we go to use this negative 2, we can think of it as negative 2 over 1, which tells us our rise over our run. So that means for each point, we're going to rise negative 2, which actually means go down 2, and go over 1. So because it's negative, this means down 2. This is positive. It means right 1. Remember, you could also go up 2, left 1. So what I mean is we could also write it as 2 over negative 1, in which case we're going up 2 and then left 1. These will keep all the points on the same line. Both are good ways to do it, and you're going to want to use a mixture of both. Okay, so we're just going to hand sketch a graph really quick. I'm going to start with my y-intercept of positive 4. 1, 2, 3, and 4. Great. Let's make some other marks. 4, 5. 1, 2, 3, 4, 5. Okay, so I can go down 1, 2 over 1. Down 1, 2 over 1. I can also go up 2, left 1. Great, and that's it. That is our line. So, again, remember, pause whenever you need. Rewind whenever you need. You don't need to wait for me to say it in the video. Cool, so that was our review of slope-intercept. Let's take a look at what we're really getting into today. Oof, I see a lot of words here. Okay, we're going to call this example 2. You should pause here, and for this example, you should write out the whole problem. It's a lot more helpful to go back and look at it when you have everything written out. Okay, it says the graph of the function f, okay, defined by f of x equals all of this. So when we have f of x, we can have a g of x, you can have an h of x, you can have a q of x, a z of x. It doesn't matter. What does matter is that each one of these represents a different function. Each letter represents a different function. Okay, so f is not g, g is not h, h is not f. So when it says the graph of the function f defined by blah blah is shown in the xy plane below. XY plane, they're just saying graph. That's all that means. It doesn't change anything. So I know that this guy here is f of x. I'm going to write that next to him. You need to remember that this one is f. Okay. If the function g not shown, okay, is defined by g of x equals negative 2x plus 5. So here's my g. It's not shown. That means I'm probably going to have to graph this myself. And then it says, what is one approximate value of b such that f of b equals g of b? So remember, these are originally f of x's and g of x's. So what do we know about what this is asking us? The first thing we know is that b is an x value. It's being plugged in, it must be an x value. So a value such that f of b equals g of b. What is this asking us here? If f of b equals g of b, that must be a point of intersection. So we know that b is an x value. We now know that f of b equals g of b is a point of intersection. So the question is asking us to find the x value of the point of intersection. That doesn't sound so intimidating when we have it like that now. Great, we know what it's asking us. We need the x value of the point of intersection. Great, all I need to do is graph this g of x right here. So its y-intercept is 5. I'm going to graph it in blue. And my slope is negative 2. Actually, just like our example. So I can go down 2 over 1, down 2 over 1, down 2 over 1, boom. Great. Right here, I have a point of intersection. What is its x value? Let's just follow it down to the x-axis, and that's 1. So the x value of our point of intersection is 1, and it wants us to call it a b value. So our b value is 1. This is our final answer. We can plug it actually back in here to make some sense of this. What we're saying is that f of 1 equals g of 1. Because when we go to 1 on the x-axis and we see what's happening to each graph at 1, they're intersecting. So when they're intersecting at 1, they both have the same value, and our answer is b equals 1. That's all for today, guys. Thanks.